Hi, so I've been asked to look at question 23, which is finding the set of values for which x cubed minus 6x is an increasing function. So we've got a cubic graph here. We need to find basically the stationary points and then find their nature so we can tell when the graph is increasing. So increasing just means when is the gradient positive or when is it going uphill. So we can start by differentiating this graph and we get 3x squared minus 6. So this is the gradient function. So our stationary points are going to be when this is equal to 0. Okay, so that's when x squared or 3x squared is equal to 6, x squared is equal to 6 over 3, which is 2. And then x is equal to the square root of 2 or minus the square root of 2. Okay, so we can find the matching y values now by putting them into this equation. So if I do this cubed, I get 2 root 2 minus 6 root 2, which is minus 4 root 2. When x is negative root 2, y is going to be minus 2 root 2, and then minus 6 times minus root 2 is plus 6 root 2, and that gives me positive 4 root 2. So we've got two stationary points at x is root 2, y is minus 4 root 2, and minus root 2, 4 root 2. Now, I like to give these context for me because I sometimes forget the values of these things. So this is about 1.41. Using the calculator here just to get the values. And this is about minus 5.7. This one obviously is going to be minus 1.41 and 5.7. Okay, so if we imagine now an axis, or draw an axis, say, we know that our two stationary points are going to be at root 2 minus root 2, one at minus root 2, 4 root 2, so that's about 5.7, and then one over here at minus that value, minus 5.7 or minus 4 root 2. Okay, so we've got that so much about these stationary points. Now we can look at whether they're maximum or minimum points by finding the second derivative. Which is going to be 6x by just differentiating this. So at x equals root 2, I get 6 root 2, which is obviously positive, which means that this stationary point is a minimum. So a U shape, so it's going to look something like that. Okay, like this. Then this one here, if I put this value in to my second derivative, I'm going to get 6 times minus root 2, which is obviously negative. So this is going to be a maximum. So it's going to look like that. Okay, now this graph doesn't have a constant value in it. So there's no y-intercept, meaning that it's going to go through the origin. So this is going to look something like this. Shoot up there, go down there. So we've got a rough sketch of this graph, and now we can just say that the increasing bits, so it's going uphill there, it's going uphill there, increasing, increasing, when x is less than minus root 2 and x is greater than positive root 2.